All right, hello everybody, and thank you so much for joining the Dedicated Show. Today, we're going to learn all about MLOps platforms and how they support the ML model lifecycle with Gideon Mendels from Comet. Super excited to have him here, and just wanted to let you know, as you're joining us across all of the various platforms, if you're joining on LinkedIn, Facebook, YouTube, Twitter, let us know that you're, where you're joining us from. It's always interesting to see the diverse audience come in. And also feel free to ask questions and leave comments throughout the session. We're not going to wait until the end of the session to take questions. We're basically going to answer them as they come. All right, without further ado, I'm actually going to go ahead and bring up Gideon Mendels, who is the co-founder of Comet. Hello, Gideon. Welcome to the show.
Hi, Kate. Thanks so much for having me. I'm super excited to chat with you today.
Absolutely excited to have you. I know you guys have a lot of news coming out today. But before we get into all of that, let's start with, who is Gideon? Tell the audience a little bit about yourself.
Definitely. No, thank you so much. So yeah, I'm Gideon Mendels. I'm the CEO and co-founder of Comet. I personally actually started my career as a software engineer about 15 or 16 years ago, but I shifted to working on applied machine learning about 7 years ago. First, as a grad student, I worked a lot on natural language processing and speech processing problems. After that, I founded another company that focused on large-scale chat analytics. So we got a lot of machine learning, about 50 models in production, which at the time I didn't realize, but that's quite a crazy number. And then after that, I was at Google. I was working on hate speech detection on YouTube comments. And I got to do a lot of research in NLP and deep learning there. And got a really great exposure on what does machine learning look like, both at a small organization, like a university, and a really large company like Google.
Very interesting. I want to hear more about that hate speech stuff. What kind of work? How did that look? What did you do there?
Yeah, definitely. So that was a few years ago, and I'm sure things have changed since. But essentially, what we were focused on is removing and detecting hate speech on YouTube comments, which I think everyone who ever used YouTube saw, unfortunately. At the time when I joined, the team actually already had a model in production. And part of the project was to try to build a better model to beat these results, right? So that was a very, very interesting project because I felt it was very important. But also, it was very challenging. We actually had a very small amount of label data. So comments classified as hate speech or not. It was a binary classification task. But we had the entire YouTube corpus that we could use for pre-training. So it was a very interesting from a research approach. And that's actually the lessons I learned there is what brought us to start Comet. So very exciting stuff.
Awesome. Great. So I'm just going to quickly check in on the comments, see who's joined us from where. Got Michael, he's from California. George Farrakhan is here. Let's see, Chandler, hello. David, Joe. George actually has a question here. So was it just hate speech in English, or did you cover other languages for that project?
Yeah, so at the time we only did English. I think now, and I don't know for a fact, but I was under the impression that they have support for additional languages as well.
Okay, all right, awesome. So we're here today to talk about MLOps platforms, right? So I think it's always good when we cover a topic, especially for maybe somebody who's not in this world, to first describe, what are some common MLOps platforms? What are they used for? So it would be good to start there.
Yeah, no, definitely. So I think in general, the term MLOps is fairly new, right? The entire world we operate in is fairly new. I think data scientist was coined 8 years ago. But MLOps is a much newer term. And the way, we like to think about it at Comet is we kind of use the software engineering analogy, right? In the software world, we have this amazing stack, database, orchestration, version control, deployment, monitoring. It's really the modern tech stack, right? So the way we like to think about it is MLOps is the essentially equivalent, but for the machine learning development lifecycle, right? So there's definitely a lot of overlap between software engineering and machine learning, but there's actually many things that they look similar, but they're actually very, very different. So that's on a high level, but I'm happy to go into details, of course, and I'm excited to talk about that.
Yeah, well, I'd like to know what are some examples of MLOps platforms that, if you can share, I don't know, 3 or 4 common ones.
Yeah, definitely. So there's a few kind of ways to approach that. So obviously you have the cloud providers, right? Like Amazon has SageMaker. I think Azure, they changed the name, but I think it's the Machine Learning Workbench or Data Science Workbench. Google Cloud also have their solution as well. So the cloud providers have some solutions there. And then you have some open source projects like Kubeflow, which is built on top of Kubernetes, which tries to solve some of the machine learning ops problems. And then you have commercial vendors such as Comet and other companies.
Okay, awesome. Thanks. Thanks for sharing that. Before I get into more questions, we'll quickly just say hello. Hi, Maria. Maria's here, and Michael says data is food. Nutrition matters. Yes.
Definitely.
Eat the right data. There you go. Before I get into further questions, I was actually just looking before the session. There was an article on TechCrunch. There's some news on Comet. You wanna share some of that news with the audience at this point?
Yeah, definitely. So today's a super exciting day for the team and the company. We just announced a lot of things. So we raised our Series A, $13 million by led by Scale Venture Partners, who is one of the most prominent VCs in the developer tools world. They support companies like JFrog and Circle CI. So super excited to partner with them. And then we also announced a new product, which is an extension of the existing platform. And I'm going to get a little bit more into details later, but essentially their new product for model production monitoring. So the step that after you finish the model, after you trained it, after it's productionized and served behind an API, how do you monitor the behavior of that model? And that is stemmed from an acquisition that we made of Stackion, which is a prominent player in that space. So yeah, lots of big stuff today and more announcements coming up. Yeah.
Wow, that's a lot of news, and I'm honored that you've still made time for this dedicated live session, even though all of that is happening right now. So thank you.
Of course. I'm really, it's great to be here, and I really enjoy this conversation where we can actually go into details and not just keep things on a high level. So I'm always down to have these calls.
Absolutely, get as detailed as you'd like on this show. We have a very smart technical audience here with us. So. All right, follow up on the question of MLOps platforms. What criteria do organizations typically use when they're trying to select the right MLOps platform for them?
Yeah, so that's a great question because this market is moving so fast. The main decision an organization needs to make is whether they're trying to go with an end-to-end solution that kind of solves all of their problems, right? From data management, orchestration, experimentation, model management, deployment, monitoring, right? There's some vendors who try to solve everything, right? Or the organization could go with the best of breeds approach, where they can pick the best of each vendor and include some built-in or homebrew solutions, right? So kind of assembling their own platform or their own stack. So that's typically the first decision organizations make. Typically what we see is companies that choose to go with the end-to-end solutions are typically either companies that don't have any internal engineering resources, right? They might have a few data scientists building models, but no support with DevOps, software engineering, and so on. Or companies that really don't view AI as a kind of core investments for the next decade. So they're really just looking for a turnkey solution that gets them up to speed fairly quickly. Most of the organizations out there, and we support some of the best machine learning teams in the world, a company like Etsy, Uber, Zappos, and many, many more. These organizations typically choose to, again, assemble like a best of breed. So they pick vendors for some of the areas that we discussed. And in some cases, they build internally and solve for areas where they have uniqueness in their needs, right? And that's typically around like the data pipelines, the data ingestion. Every business looks very, very different. So it's hard to get a vendor that would just like solve all your problems for you.
Yeah, I bet. And I feel like that's a common theme across several other areas in the data science space where you might need to work with multiple vendors, and depending on your situation, one is much better for your situation than the other. So I guess it's a case by case basis, right? There's no go-to at this point.
Definitely. And I think it's showing that the market is maturing, right? Like if I go to a software engineer and tell them, hey, I have this one product and it's going to replace GitHub, MySQL, AWS, Jenkins, and New Relic, and here's your weblogging, good luck. They're probably going to tell me I'm crazy. And in our world, it started with, it's, again, fairly new industry. So I think those end-to-end solution made sense maybe 3 or 4 or 5 years ago. But now as these organizations evolve, it's just really not serving their needs.
Yeah, and I wanted to ask, from a risk perspective, do you think that's something a company would want? Let's say, one enterprise that can handle all of that, because you're essentially putting your entire process into their hands. And I don't know if that's a good thing or that's a bad thing.
Yeah, I mean, again, it depends on kind of the DNA of the organization, but like I said, we see more and more of these teams decide to kind of pick and choose and build their own stack for their needs. There's a lot of benefits, like you said, that reduces the risk, so you're not kind of bought into one vendor, especially if you're a small company and you have no way to affect the roadmap. But also, typically, it allows you to be more flexible with cloud providers. You could go multi-cloud. You can switch cloud providers. You're not kind of baked into one solution. And that's very similar to what we're seeing in the software engineering world.
Thank you for sharing that. We've got a question here. Dr. Vytatas from Lithuania. Are the terms of machine learning engineering and ML ops, do they cover the same aspects? Could he interpret these terms as the same domain?
Yeah, so that's a great question. And a lot of the confusion stems from the fact that these terms are kind of over time defined by the industry and no one actually exactly defined them. So I guess the answer is yes, but also no. Typically, when we think about machine learning engineers, we think about the persona that's focused on taking the trained model and really working it into production, usually in more complicated cases. So whether it's figuring out the feature engineering pipeline, how do you do batch predictions, really like the core of that model in production. Most of the people that we see that are building the MLOps platforms actually have a software engineering title. But that said, 4 years ago, everyone at Google, or 99% at Google, Googlers who did machine learning were called software engineers. So I definitely expect that to evolve as well.
Yeah, that's very interesting. I keep hearing there's a great correlation between, like you mentioned, the software development lifecycle and then maybe the machine learning model lifecycle. So maybe we touch on that a little bit and walk through what are some of the high-level steps for a machine learning model lifecycle. If you can bake in some of the differences between that and the software development lifecycle, that's great. But I do want to focus on the machine learning side of things.
Yeah, definitely. So there's, like we said, there's a lot of similarities. There's also a lot of differences. And most companies and teams, usually the first thing they try to do is use the software engineering methodologies and tools that they know. And sometimes it works, usually it doesn't. In the machine learning world, right, like it's a research-driven process. So it's very hard to estimate how long it will take to build a model, or if it's even feasible, right? With software, we know with enough engineers and enough time, we know beforehand whether we'll be able to build it. But with machine learning, you go into a project and you might get a good model in 2 weeks. It might take 2 years, and you might never succeed, right? That's one of the challenges in doing this job. But typically, when we think about the workflow, and obviously depending on which task you work on, but typically we start by doing EDA, right? Exploratory data analysis, looking if there's any signal in the data, if there's anything that tells us or gives us hints on how we should think about modeling it, right? And that process again could take like 3 days or could take 2 years. It's hard to put estimates on that. But once we have a good idea of how the data behaves, we typically go into a feature engineering process. Now, again, depending on the task, in some cases, especially these like deep learning use cases, we don't do a lot of feature engineering. I'm just trying to keep it fairly generalizable. But again, in feature engineering, we're trying to like extract information from the data that will help the model make better prediction. And then we go into like the experimentation and the modeling piece. So typically in that case, there's a few components. The most critical one is figuring out what metric are you using to measure your model. We've seen a lot of teams fail there. For example, if your business is, if your use case is extremely sensitive to precision, for example, but you're using an F1 score instead of directly precision, that will obviously affect the downstream business and product KPIs. So defining the metric is the single most important thing, and which is also, by the way, very hard. But the single most important thing you could do to improve the success of your project. And once we have a solid metric, we can start experimenting and benchmarking different models. So this could be different algorithms, different modeling techniques, different hyperparameters, what typically called the model selection process. And then hopefully at some point we have a model that behaves in a way that we wanted, and then the metric is good enough by some kind of business standard. And then we go into like the deployment phase of things, right? So we have to take the train model, the binary, in the most simplistic ways, wrap it up with some REST API and put it in production. I'm very like overly simplifying things here. But that's in a high level. And then once you get to production and your model start making prediction on production data, you really want to start looking at how is it behaving there and whether it's behaving the same way you thought it will. That's very important, right? Because that metric that we use during training is typically an offline metric. But then for the first time, we can actually see the online metrics, the product KPIs, the business KPIs changing. And then that point, usually we start iterating. So we put the model usually for a subset of the data, a subset of the users, subset of the traffic. And then we start seeing how it behaves. We go back to training, we tweak things, and that keeps going for a very, very long time.
I had a question here. So you mentioned putting it into production. I don't remember the exact statistic, but from what I read, or several times I read this, there's a very low percentage of machine learning models that actually go into production. Can you talk a little bit about that and why?
Yeah. So I think they say about 80 or 90% of machine learning models never go to production. And I was very curious about that, because deploying a model is not very hard. I'm not saying it's easy, but I've never in my life, and I spoke to thousands of machine learning teams, never in my life met a machine learning team that had a model that was good enough and they couldn't figure out how to productionize it. There's a lot of tools, there are a lot of processes, and that specific piece is usually not that far off from like how we deploy an application. The reason 80 or 90% of these models never reach production is because they're not good enough. They're not meeting that business KPI, right? And that's also like one of the reasons why we're seeing such a huge demand for like these data labeling solutions, because the typical approach is like, we need more data, right? So that's at least from our perspective. But if someone here is kind of struggling figuring out how to deploy a model, there's like a lot of great open source solutions. There's great vendors there. The cloud providers all have very simple ways to do that. As long as you have the train model, the binary, and you're using one of the popular machine learning libraries, you can probably go to production within a day.
Wow. Okay, that's good to know.
Yeah.
And then a question while you were talking about the life cycle. David asked, does this all depend on the industry? Because I guess it would be a custom approach for each area.
Yeah, so it definitely depends on a lot of things. It's not as much as industry as it is with the specific machine learning tasks, right? So if you're trying to predict customer churn and you're marketing tech, or you're in pharmaceuticals, that process, other than maybe HIPAA compliancy issues, won't look that different. But if you're doing, if you're training a model on tabular data and you're doing a computer vision project on images, that looks completely different. Yeah.
I bet. I'm sure there's some things you can transfer across industry, but some things will get pretty specific. Quick question from Angeline here. I'll respond to this one. She's asking if this is going to be recorded. Yes, Angeline, this is recorded, and this will be up on YouTube on the dedicated channel. It'll stay on LinkedIn as well if you want to just save that link. But sometimes it's easier to rewatch something on YouTube if you wanted to scroll. Now, Harpreet is here. He's just saying hello. Hi, Harpreet. Good to have you here. A question here from Michael. He's asking, when it comes to MLOps, what's the optimal number of people to bring into projects? To bring projects into production, sorry. Is it better to have one or two people involved, or are more people needed?
Honestly, it really depends on the team, the model, the project. There's a lot of things that come into I mean, it's very hard to answer in a high level, but again, I mean, you can probably go now and figure out how to deploy a model alone within a few hours using open source cloud providers. So that isn't necessarily the issue. If you have a very complex stack, very complex engineering organization, then you might need more people involved. It also depends who in the organization is in charge for deployment. Sometimes it is the data science machine learning teams. Sometimes it's the application team. So hopefully I gave you some sense, but it's just very hard to answer on a high level.
Of course. It's almost like the industry question, right? I guess it depends is a very common answer with these types of questions. Awesome. All right. A question from Gabrielle, who's interested in knowing the specific topics in which MLOps differs from standard DevOps. And I guess you touched on this already, but if you want to do a quick answer to that one.
Yeah. So on the development side of things, right? Like, so in machine learning, code is just one piece of the puzzle, right? Where in software engineering, it's 90% or 95%. In machine learning, we have data coming in, hyperparameters, results, models, all these other pieces. And that's why like solutions like GitHub, which do an amazing job for version control for code, do not give you the necessary support for these other pieces. And then when we think about kind of like the deployment itself. So actually like getting like the CI/CD methods that we know, that's actually not very different, I would say. Again, I'm generalizing here, but in a high level. And then where it's really, really different is the monitoring piece of things. So in application or software engineering, using tools like New Relic and Datadog, we're looking at both like infrastructure metrics, but also, which API calls are taking too long, where there's errors and such. But none of that applies to these models, right? Like when we think about monitoring models in production, we want to look at the distribution of features over time, right? Do we have an anomaly? Is our model still predicting high quality predictions like it did during training? How is it affecting the business KPIs, right? Like how different models behave. So it's under the same category of monitoring, but it's actually a completely different solution.
Yeah, and Michael just saying thank you for your answer there. So the other question I had for you was, we're talking about the machine learning model lifecycle, and basically how do the MLOps platforms support this, and maybe discuss some of the challenges that companies face when they're trying to implement these solutions.
Yeah, definitely. So again, there's multiple pieces in that life cycle, but essentially what these platforms do is the product and the value proposition is tailored for these specific needs, right? So, for example, if we take the development process, right? So we talked about GitHub, which is we have this kind of Git workflow that a lot of developers love. You write some code. Once you get to some kind of meaningful state, you commit it. You create a pull request. Some people review the pull request, accept it. It goes up to staging. All that workflow that we know doesn't really work for machine learning, right? So solutions like Comet and others that focus on development, there's a lot of differences, right? So for example, specifically with Comet, there's no CLI like Git, right? So we actually live inside your code, and the reasoning there is we want to allow you as a developer to iterate quickly and not have to go and commit and push every time, because it is an iterative process. Additionally, tracking the hyperparameters, the configuration, the results, all these other pieces. So that's like one example how these platforms tailor it and help with that specific use case.
Okay, yeah, thanks for that. You mentioned Comet. Let's finally talk all about Comet, right? That's the big topic here. I'm really curious to find out a lot more about the company, how you got involved in the beginning, and how does Comet help solve some of these challenges?
Yeah, definitely. So we actually came up with the idea for the company, or we saw the pain from my experience at Google. We saw it earlier, but when I started Google, which is arguably the company with the best developer practices in the world, and saw how many challenges and pain there is around these projects, that's really where things clicked. So specifically there, like I mentioned, I was working in hate speech detection. The team already had a model in production. The project I was in was in charge of trying to build a better model. Mm-hmm. And when you try to build a better model, I guess the first question you ask is, what is this model I'm competing with, or what's in production, right? And to our surprise, we had a very hard time answering that, right? So we had the code because it was checked into the equivalent of GitHub or a Bitbucket, but we didn't know which data set they used to train it, what are the hyperparameters, and not even like the exact results. Like we had to pull stuff from emails and slides and all these. And then given how challenging that was, we actually decided to start from scratch with like a baseline model just to see how it behaves. And to our surprise, the baseline model, which was like the NLP 101 scikit-learn approach, actually beat the deep learning production model. And that where things really click, where like if you don't have these processes and tools in place, you're not going to be successful, or going to have a very hard time being successful. So we took all that knowledge and we started Comet. And essentially what we do today is we work with data scientists and data science teams, machine learning teams, AI teams. Again, there's terminology in our space is a little bit vague. And essentially what our platform allows them to do is manage the entire development process of these models. So tracking their data sets, their code, their experiments, their models, their results, whether that's in what's called offline experimentation during training or post-production during monitoring these models. And on top of that kind of standardized system of record, we provide collaboration capabilities. So Kate, I can send you like an experiment I worked on, and you can see everything you need to know about that model. There's no questions asked. But also we have insights that allows these teams to like understand how this model is behaving, why one model is better than another, and really try to drive that research process and hopefully get closer to that business KPI or better even than to that business KPI, because that's really where the core issue is for these teams.
Interesting. So I'm eager to see how this works. Can we do a quick demo and show the audience as well, maybe some of the behind the scenes and how all this works?
Sure, definitely. Yeah, love to. Let me share my screen. Nice. So one thing before I jump in that's important to mention, so this is on what we call our community edition, which is actually free. So if you're a data scientist and you want to use it, you can just go to comet.ml. The majority of our large enterprise customers are running this entire product and platform on-premise or on a VPC, virtual private cloud. But I'm going to demo this on the community edition. Essentially, this is what a data scientist would see the first time they log into the platform, right? So we support all the popular machine learning libraries, both for deep learning and traditional machine learning. If you're using something that isn't listed here, you can still use Comet. You just might have to do a little bit more work. And for most of these use cases, the only thing you need to do, you pip install the Comet package, and you add these few lines of code into your existing training code. So whether it's a Jupyter notebook or a script or a full pipeline, you just add that in there, and that's it. We will actually take everything from there. And we're also agnostic to where this model is training, whether it's on your laptop or on a cloud provider, on a private cluster. It doesn't really matter. So as soon as you start running, this model will start reporting results to Comet. For the sake of preserving my CPU from blowing up, I will not try to train a model while I'm on a live webcast, but I do have an example here. So this is what would you see when the model starts training, right? So we're in what we call an experiment. And the first thing we see are these like real-time training metrics. So here we have accuracy and loss, and these are transmitted in real time from the training job. Now, nothing here was predefined. Everything was actually collected automatically. But of course, if you want to customize this view, you can add chart, you can save it. There's a lot of flexibility here. So what I'm going to do, I'm going to go through the tabs here on the left. But if anyone has any questions, of course, feel free. I'm happy to answer them. So if I click code here, you can actually see the actual training code that was used to train this model. And we do this by actually integrating with the underlying Git layer. So we believe Git is the best tool to manage and version code. And we actually allow you to continue using it. So for example, if I click, specifically this one wasn't using Git, but if I click the reproduce button, I'll get all the Git information. So it's synced with your repository. We also track all the hyperparameters that was used to train this model: learning rate, kernel size, filters, and those, again, none of those were predefined. We actually pull that from the internals of the machine learning library for you. All your metrics, these are, again, pulled automatically, but you can report manually if you want to. Standard output, so you don't have to SSH into an instance or anything like that. Information about the system, all your dependencies, so you know exactly which version of scikit-learn or TensorFlow you use, and this is very important for kind of reproducibility purposes. And then we have these set of modules which are task specific, right? We talked about tabular data, computer vision, audio. So I think this one didn't send any debugging data, but I have this one right here. And yeah, there you go. So this is another experiment, and you can immediately see it behaves in a similar way. But here I'm looking at this confusion matrix. So for those of you who are unfamiliar with confusion matrix, is a way to kind of inspect the model predictions. So essentially everything in the diagonal means the model got it right, and everything that's outside of the diagonal is a model mistake. So in this task, this is, let me see. Yep, this is the MNIST data set. So we're trying to detect handwritten digits into the actual integer. It's a computer vision problem. So for example, this cell here is images of the number 0 that the model has predicted as 3, right? And the exciting thing here is that we can actually click on these and see these predictions. So these are 2 misclassified as 6. And, you know, I think this model is probably not great, but if you look, for example, at this one, you can squint and you can see why the model got it wrong. And this really helps to drive the research process, because it tells you, do you need more data, or your labels are not good enough, or there's an issue with the model convergence, right? There's a lot of ways to kind of inspect that. And we have similar modules for different use cases, and there's just kind of like a lot more there. But I wanna take a step backwards and show you guys the kind of like the full project view. And by the way, Kate, if there's any questions or anything, I'm happy to answer them.
I had a quick question personally. So what happens when you click on one of the blue squares? I'm just curious, because it has a lot more values.
Yeah.
Okay, so
these are the correct classifications. Yeah, exactly.
Okay.
Yeah.
Got it. Yeah, that's interesting. So there's a question here from David. Can I export the results and graphs? Some managers prefer Tableau or Power BI or even Excel.
Yeah, definitely. I'll show that in a second. We also have a built-in reporting feature, so you can build a report and share that with your manager. But everything is, you can export everything both from the UI and there's APIs to do everything. I'll touch on that in a second.
Okay.
So what I'm going to do now is essentially, we saw this experiment, right? If I click the project name here, this one's called Parameter Space Exploration, it will take me to this page, right? So let me start with the bottom here. We have this like long table. Each one of these is an experiment, like I just showed you. So if I expand this, you can see they behave very similar. But the cool part here is now that we reported all of our experiments, we can start looking at our project in aggregate. So of course, I can see kind of like the hyperparameters that are used, but I can also build these like visualizations on top of it. So for example, here on the left side, we can see the loss of each line here is a different model from the table below. And we can see how each model behaved. You can see, for example, right away that a lot of these curves are pretty spiky, which typically means, and I'm being careful here, typically means your learning rate is a little bit too high. So that's just a way of like an insight that I can pull very quickly. And if you're a manager, you might be only interested in like test accuracy, right? You can get that here as well. But we also have ways of really understanding the entire process in aggregate. So for example, this visualization, which is called the parallel coordinates visualization, is super exciting. So every axis here is a different hyperparameter. Every line is a different model. And the more orange it is, the higher the accuracy is, the better the model is. Okay. So what we can actually see, for example, if I look at kernel size here, I don't know if this is small. I'll try to zoom in a little bit. We can see that most of the orange lines actually go through this point, right? So when kernel size is set to 5. So what I can do, I can actually select this. And what I'll zoom out again.
I see it changing up, yeah.
Yeah, so now I actually filtered only these experiments, and I can see how these behaves again. And that really allows me to understand. I can go back to the table, look at the ones that are visible, select one of them, reproduce it by clicking here, and you can see this is the Git information. So I can just copy paste these commands, roll back my repository in time, and continue my training job. And then let me go back here. So exporting, by the way, is available here. You can export a CSV right here. Very simple. And yeah, I'll just show a couple of other things. By the way, Kate, feel free to stop me if you have any questions.
There was another question here from Carlos. He's asking, does this work on local PCs also, or does he need Comet.ml infrastructure?
That's a great question. So that's what I started saying. We're completely agnostic to where you're trying to model. So if you have a code on your local PC, just add these 2 lines of code and you'll be ready to go. You don't have to use any of our infrastructure. So one thing I want to show you, some of these visualizations were already here when we joined this, but what I can do, I can actually add panels here on the right. And you can build any type of visualization. So if you're using BI tools, this is probably familiar to you. But one of the most exciting things is we realized that all of our customers and users can code. So we actually give you the ability to build your own visualizations with code. So let's see how that looks like. If I click create new here, give it a second, it will open up our visualization builder. Okay. So what you can see here is you have full code access. And then on the right side, you see the panel. And what's cool about this is unlike, visualization you might build in like a Jupyter notebook, this is pulling the data through the Comet API. So, for example, this is getting all the metrics for an experiment. What that means is you build this visualization once, and every time you'd report a new experiment, it will actually automatically update. So it's dynamic. And this works with reports. If you want to share with your manager, like basically a dynamic report or a dashboard, you could do that as well. And one of the things that happened after we released this is the community started building all these amazing panels and contributing them. So if I click public here, you'll see, and it takes a second to load, but you can actually see panels that the community contributed, right? So you have so many things here, right? Like looking at optimization reports, ROC curves, visualization, export, like there's 130 of them here. It's kind of like an app store. And because it's all built on this unified API, you just click add and it will work for your project. So super exciting about that. Yeah. And another side of this is we've seen a lot of our enterprise customers use this functionality to kind of customize the system for their own use case and integrating it to their the rest of the process.
Yeah, it's really cool.
Awesome. So I can cover reports. I can answer questions. You tell me what makes more sense, Kate.
All right. Let's address some questions, and then we might go back depending on what questions people have. A question here from Vito. Is it possible to integrate MLOps with an explainable framework to get automatic explanations with experiments? Yeah, definitely. So those panels I've shown now, there's panels there for explainability methods like SHAP and LIME. So you can just add those, and you might need to add additional code just because you need to create the explanations locally. But yeah, that's already built in, at least on Comet. Yeah. Okay, awesome. And David thinks this is a cool feature. So thank you. Just compliment here. Question from John: is Comet connected in a manageable way with some of the infrastructure providers as code like Terraform? Yeah, so if you opt in, if you're an enterprise customer and you opt in to install Comet on a VPC or on-prem, we have about 10 or 15 installation flavors, including Terraform is one of them. So it's very, very flexible, but yeah. Okay, thank you. I had a question myself in terms of people who are seeing this right now. Is there a free trial available, or how can people go in there and start trying this out? Yeah, so if you go to Comet.ml, click sign up, you're actually going to get a free account for free. So it's completely free for individuals, 100% free. If you are an academic or a small startup, you're actually going to get the full-fledged plan for free as well. So, and then if you're part of a larger team and you're looking to heavily invest in using something like Comet, then you can also, of course, get a free trial. Awesome, thank you. Yeah. Question here from Harpreet, kind of taking us back a little bit in what we were touching on earlier. But what's the biggest challenge that you've seen startup data science teams face when it comes to version controlling their ML experiments and resulting models?
Yeah, Harpreet, that's a great question. So typically, like when we started this, we interviewed about 150 data scientists, and we asked them, "How do you track your experiments and models?" Right, and the majority of them, unfortunately, didn't. Right, so they kind of remembered, which is very common, I think, in our industry. Some of them use Excel sheets. The problem of all these like homebrew methods, using Excels, using notes, and so on, is you typically don't have all the pieces of the puzzle. So you might write down, I tried this modeling approach and this is the result I got. But when you come back 2 weeks later, a month later, you want to reproduce it, you want to know exactly like which data set, what hyperparameters. So that's where things starts to break down usually.
Mm-hmm. Yeah. And another question kind of related to what we were just talking about from John. What do you think is the best orchestrator that currently exists to make an end-to-end implementation that can provision each step job execution in an easy-to-handle way that can be used in the main clouds and have a vocation towards MLOps? I'm going to take a guess here and say Comet, but you go ahead and answer that.
No. So we're actually not an orchestrator. We cover, I think the question was specifically about orchestration. I think the keyword here is easy. I don't know of an easy orchestrator. There's a bunch of solutions. So Kubeflow is, I guess, the one that the mostly geared toward MLOps. But then you have the traditional ones like Airflow, which is still super popular, and Luigi.
Mm-hmm. Okay, thank you for that.
Yeah.
Just making sure that I didn't skip any of the questions. Oh, there we go. I did. So this is from a LinkedIn user. That means they have their privacy settings on, which is fine. So thank you for the session. Can you share any insight as to how to determine when to retrain or go back to the drawing board with the ML model that's in production?
That's an excellent question. So I'll start with the wrong answer, and that's what most teams do today because they don't have a better solution. Is you start seeing the business or the product KPI being hit, right? You start seeing a degradation there, and they're like, okay, something's wrong with the model. But obviously, we want to catch those things before they start affecting the product KPI. So the best way to do that is to look at, and this is, again, task dependent, but look at what's called model drift, right? So if the distribution of features in production is different than what you train your model on, it is very likely that it's not behaving in the way you expect it to. Mm-hmm. And that's why, actually, at Comet, we believe that experimentation and model management and model monitoring are going to converge into one category, because in order to answer these questions in production, you need to know what happened in training, right? And you saw on my demo, we have all this information, and we can actually cross-reference and say, give you an alert, something's off with the model, the distribution has shifted, and we don't have to guess because we can actually compare it to training.
Mm-hmm. I think this might also be a good time for us to talk about the new product that you mentioned earlier, if you want to touch on that.
Yeah, so that really one of the core value propositions for this product is exactly that, answering exactly that need, right? How do you know when you need to retrain or when you have an issue with the model? So the way this works is, again, we track the distributions of features and predictions over time in production, right? Mm-hmm. And then we compare it to the training distributions, right? And we do everything automatically for you. So whenever there's some kind of an issue or something might go off, we'll give you an alert. Additionally, we have this investigation feature. So if you see a prediction that looks like it's behaving a little bit off, you can actually double down into a production prediction and look at the features that came into it, look at the results, and look at some explainability methods around it. So that's really the core focus for that product. It's tightly connected to experimentation because of that added value that we identify by looking into both of these things in a holistic way. It's currently only available for an existing enterprise customers, but it will be available for the rest of the world in the next few weeks.
Awesome, exciting. Can you talk a little bit more about that alert feature? Is that something that will just let you, do you have to add yourself to some kind of list, or I'm sure you set up the alert beforehand, right? And then if something triggers it, everyone gets an email, or how does that work?
Yeah, so there's multiple ways you can define alerts. You can say, if this number goes above a certain number, or you a specific numbers of standard deviations and so on. But yeah, you set the alerts before, and then once an alert hit, there's kind of multiple ways. We have integrations with PagerDuty, Slack, emails. So it really depends on the customer needs.
Okay, great. Bunch of questions came in. We'll try to get through as many as we can. Question from Rahendra: what parameters can you track with Comet?
Yeah, so I haven't covered the code side, but we're completely agnostic. So there's a very simple function called log parameter. So you can report anything, integers, strings, lists, whatever you want, and then everything you put into the platform, you can build these visualizations on top of. So really, the answer here is everything.
Okay, everything. Awesome, easy answer. Abel's asking, does Comet also support ML Flow?
Yeah, definitely. So if you're using ML Flow, you can actually include the Comet import and create an experiment. And if you already instrumented your code with ML Flow, we'll actually pull all of that automatically as well.
Okay, great. Sorry, I'm kind of going rapid fire here. I want to get to as many as possible. So Carlos, and I know you touched this a bit already, but Carlos is asking, how does Comet do data version control?
So again, with this one, the answer is it depends, because there are multiple types of data types, streaming data, stale data. There's a lot of questions there. We have multiple ways to support that, and actually, we're going to release even a more robust functionality in the next few weeks there. But on a very high level, you can track the actual artifacts, like the files. You can upload them to Comet, and we can connect and show you where they came from and which experiment consumed one or produced one. Or you can actually connect to like a remote source. So if your files are in S3, for example, or in a database, you can connect as well. So it really depends on the needs of the customer.
Okay, thank you. And then another question from Carlos again. How do you usually check your feature distributions on production?
Yeah, so that's not something the customer, the users have to worry about. We have kind of like methods on how to compute that in real time, and it's a very challenging data engineering problem because the throughput is very high. But we essentially take care of that for you.
Okay, well, Gideon, I want to say thank you so much. I know we've covered a lot, and people are still coming at us with questions, but I'm hoping either you or someone from your team can hop in onto LinkedIn at some point afterwards and maybe address some of the ones we didn't get to. But last question I usually ask my guests is, where can people go to learn more about the work you're doing, or to get in touch if they had, if they wanted to continue this conversation?
Definitely. So if you're part of a data science team or a machine learning team within our organization, we welcome you. Come to our website, comet.ml. You can schedule a demo with us, and we're happy to go through a demo that's tailored to your own needs. If you're an individual, a startup, if you're an academic, you can just actually go ahead and get direct access to the platform for free. It's all available on comet.ml. Great.
Well, thank you so much for this session, and huge congratulations on all of your various news that's come out today. Thank you for the live audience who's joined us, and those listening to the recording, thank you as well. It always helps when people engage with the conversation, so I definitely appreciate all the great comments and questions that came in. And at this point, I just want to say, Gideon, thank you again, and I will see everybody online.
Awesome. Thank you so much, Kate, and thanks for everyone who attended and asked questions.